From this distance, it is genuinely beautiful. The colors alone look like something painted by hand. Burnt amber, deep rust, pale ivory, soft bands of cloud wrapping the planet in slow, trustful spirals. It looks calm. It looks ancient. It looks almost peaceful. That pale oval near the equator, Amor, the one that has been turning for at least 400 years, is wider than the entire planet Earth. And inside it, right now, the wind is moving at 550 kilometers per hour. We have known about this storm for as long as we have had telescopes powerful enough to see it. The first recorded observations go back to the 1660s. That is older than the United States, older than the Industrial Revolution, older than modern medicine. It was here before all of that, and it is still here now. The Great Red Spot is not a storm in the way we understand storms on Earth. On Earth, a hurricane forms over warm ocean water, draws energy from it, and eventually dies when it moves over land or cool water. It has a beginning. It has an end. This does not. Jupiter has no land, no ocean surface, no solid ground of any kind. The atmosphere simply deepens, layer after layer, for thousands of kilometers, growing hotter and denser and more violent the further down you go. The storm has nothing to run out of. It feeds on the planet itself. The Great Red Spot stretches roughly 13,000 kilometers from one side to the other. That is wider than Earth, and it reaches at least 300 kilometers down into the atmosphere, possibly much further. Scientists believe the roots of this storm go deeper than we have ever been able to measure. We tend to imagine Jupiter as distant and abstract, a dot in the night sky, a colorful photograph pinned to a classroom wall. But imagine for a moment that you are there. Not deep inside, not in the worst of it, just at the very top. The cloud layer, the entry point, the first threshold. You are approximately 50 kilometers above the deepest part of the storm clouds. The temperature here is around minus 145 degrees Celsius. The wind is already moving at 500 kilometers per hour. That is faster than the speed of sound on Earth. Not a gust, not a peak. The baseline. For comparison, the most powerful wind ever recorded on the surface of Earth was 307 kilometers per hour. That wind destroyed everything in its path. The wind you are now standing in is nearly twice that speed, and we have not even gone deeper yet. A human body exposed to this would not survive long enough to experience the cold. The wind alone would tear the structural integrity from any vessel we have ever built or currently know how to build. Let us go further. Let us descend. You enter the upper cloud deck. The light fades. The sky above you, that beautiful amber and ivory you saw from space, closes over you like a lid. The first thing your body notices is the pressure. At the top of the clouds, the pressure is already comparable to Earth's surface, but you are dropping. And with every kilometer you descend, the pressure climbs. Your eardrums exist to detect tiny changes in air pressure, the kind that carry sound waves. They are extraordinarily sensitive. At 10 kilometers down, the pressure has increased to the point where the thin membrane of your eardrum simply cannot hold. It ruptures, both of them. Not painfully. There is no time for pain to register before the next thing begins. Your lungs are designed to exchange gases at one specific pressure. The tiny air sacs inside them, millions of them, thin as tissue paper, inflate and deflate roughly 15 times per minute on Earth. At this depth, the pressure is so far beyond what they were built for that those air sacs begin to collapse inward. They do not tear dramatically. They simply stop being able to function. The exchange of oxygen into your blood, the process that keeps every cell in your body alive, stops. Your heart is next. It is a muscle. All muscles require oxygen. When the oxygen supply is cut, and it has now been cut, the heart begins to lose its rhythm within seconds. Not minutes, seconds. The electrical signals that keep it beating in sequence begin to fail. The chambers fall out of sync. The heart does not stop dramatically. It becomes chaotic. Then it becomes still. Your eyes, the blood vessels in your eyes, are among the smallest in your body. When the cardiovascular system fails and pressure spikes simultaneously, those tiny vessels burst. Not just surface vessels, all of them. Your organs, the liver, the kidneys, the stomach, the intestines, are held in position by tissue and pressure equilibrium. That equilibrium no longer exists at this depth. The external pressure now far exceeds the internal pressure. The organs do not rupture outward, they compress, they fold. The structural arrangement that kept you alive on Earth becomes irrelevant here. All of this happens in under 2 minutes, possibly faster. Here is what makes this different from almost any other dangerous environment we can imagine. Most dangers have an exit. A burning building has doors. A sinking ship has the surface. Even the deep ocean has an upward direction you can move toward. This does not. The geometry of the Great Red Spot is the reason. This is not a storm that moves in a straight line. It is not a system that blows outward and disperses. It rotates, counterclockwise, continuously. And the rotation is not random. It is a closed system. The winds circulate inward and downward. Anything that enters the system does not drift outward with time. It is pulled inward and then pulled deeper. There is no upward current strong enough to oppose this. The vertical forces inside the storm drive material downward. The horizontal forces drive it in circles that tighten rather than expand. If you entered the outer edge of the storm, even at the very top, the mathematics of the system would carry you inward. Not immediately, not in a straight line, but inevitably. Now consider what it would take to leave under your own power. To escape a planet like Jupiter requires moving fast enough to break free of its gravitational pull entirely. Jupiter is the largest planet in our solar system. Its gravity is 2.5 times stronger than Earth's. The speed needed to escape it is approximately 60 kilometers per second. That is 60 times faster than a rifle bullet. The mathematics of rocket science creates an impossible loop here. More shielding to survive the pressure and temperature requires more mass. More mass requires more fuel to accelerate. More fuel requires more mass to carry it. The numbers compound on themselves until the required vehicle would need to be larger than anything physically buildable, and it would still be destroyed by the environment before it could fire a single engine. The storm does not trap you by intent. It does not pursue. It does not choose. It simply exists as a physical system. And the physics of that system has only one direction: deeper. We did not arrive at this understanding through imagination alone. In December 1995, NASA sent a probe into Jupiter's atmosphere. Not into the Great Red Spot, not into the most dangerous region, into a relatively calm section of the upper atmosphere, a quieter area that scientists had specifically chosen because it appeared to be the most survivable entry point available. The probe descended for 58 minutes, in the calm part. Then the pressure crushed it entirely and the signal went silent. It did not transmit a final message. It did not send a distress signal. The probe simply ceased to exist as a functioning object. The last data it sent showed temperatures climbing past 150 degrees Celsius and pressure at 23 times what we experience at sea level on Earth. And it was still descending, still in the upper layers. Scientists estimate it was destroyed well before reaching the deepest measurable layers of the atmosphere. In the Great Red Spot, where the winds are faster, the pressure gradients are more extreme, and the atmospheric violence is orders of magnitude beyond the calm zone, the Galileo probe would have lasted seconds, perhaps less. Years earlier, in September 1977, NASA launched Voyager 1 on a trajectory that would take it past Jupiter in March 1979. As it flew by, never entering the atmosphere, never going anywhere near the storm, it captured the first detailed imagery of the Great Red Spot in motion. What the data revealed was not just a visual record. It revealed wind structures, temperature gradients, and circulation patterns that confirmed what the mathematics had long suggested. The storm was self-sustaining, deeply rooted, and geometrically closed. The outer edge of the storm showed winds feeding inward at speeds that increased rather than decreased toward the Centauri. Voyager 1 flew past. It did not linger. It did not descend. And even from that safe distance, the data it captured was enough to tell us everything we needed to know about survival inside that system. None of it was encouraging. Wind speed: 550 kilometers per hour. Storm width: 13,000 kilometers. Wider than Earth. Storm age: over 400 years, possibly much older. Pressure at depth: over 1,000 times Earth's surface pressure. Temperature range: -145 at the top. Thousands of degrees deeper down. Gravity: 2.5 times what your body was built for. Direction of all internal forces: inward, downward. Time to human survival: seconds. Gone. We are a species that has walked on the moon. We have sent machines to the edge of the solar system. We have looked back at our own planet from billions of kilometers away and described what we saw. And yet, there is a storm on the planet next door that has been turning since before our grandparents' grandparents were born. since before nations with their current names existed, since before we understood that other planets existed at all. It was turning while we were still figuring out how to sail across our own oceans. It does not know we are here. It does not care that we have named it. It did not pause for our wars, our revolutions, our great discoveries, or our great failures. It will not pause after we are gone. The Great Red Spot is not a threat. It is not malevolent. It is simply a fact of physics on a scale that makes everything we have ever built look like something drawn in pencil on paper. We look at it through telescopes, and it is beautiful, and it will never let anything in. I hope you found this as humbling as I do.